Hi, everybody in the audience. We're going to go ahead and start a little early since it seems most of you are already here. Welcome back to the VGDC. It's so good to see so many of you back. It's a bit of a rarity in the past few years with COVID and everything going on, so it's really great to see. So tonight we're going to be doing a presentation on Game Dev 101. So this isn't really going to get into specifics of any software yet. It's mostly just going to be more conceptual, how to go about, planning, what to do, and how to go about building a team, finding what you want to do and what you want to focus on, because that's a big part of kind of learning, is trying to pick a lane and specialize. Because it's good to be a jack of all trades at first, kind of explore, but eventually you want to specialize in something, because then you'll just be a master of none if you stay being a jack of all trades. All right. So first up, what is a game developer? Does anybody know? Is it a technician or a programmer? Someone who develops games. That's a good answer. Is it an artist or a musician? What about a director or a producer? The answer is they're all game developers, as I'm sure you all guessed. A game developer is anyone who works to bring a game from concept to reality. So just it's a blanket term, and game developers are, it doesn't necessarily mean you have to be in the engine doing something. You can write on a piece of paper that never touch a game engine. You still help develop a game. And you are a game developer. So starting out, we're going to go over the aspects of game development. These are going to be the major ones that we know and that we're going to be teaching this semester. And then there's kind of going to be a list of some other ones that we also know about that we'll recommend. And if you would like to help us grow that into our repertoire of things that we normally teach, come talk to us officers. I'm the president. We've introduced ourselves, so hopefully you know us. If not, come talk to me and I can point some of us out. But yeah, so aspects of game development. First up is game design. So game design, the best way to describe it is it's effectively games on paper. This is everything about your game on a sheet of paper, no actual implementation done. You want to know what the art is going to be like, what is the theme of the thing, what's the writing going to be, what is this level going to look like, where are all the different secrets in that level. You want to try to design out as much as you can. Now, you're not going to be able to design out everything. You'll make a design doc, and eventually you'll get into the thick of things, and you'll have to make edits or changes, or you'll be like, oh my gosh, how did I not think of this amazing idea before? And you'll add that in. But the idea is to try and develop a really good document to start, and then make sure that it's good at communicating your ideas, because this is also what everyone working on the game with you is going to be using to base their work on. So game design basically refers to all the planning and the prep work that goes into it. It has a bunch of different sub-disciplines. It's not just game design, overall. You have gameplay design, which is more, the moment-to-moment doing control clicks and stuff. You have the world design, which gets into kind of layout, exploration. You have UI and UX design. For those who don't know, that's user interface and user experience. So the user interface is the kind of heads-up display that's on your screen. It's all the different buttons and stuff and prompts that pop up on the screen. And then the user experience is what the user's psychological experience is when they're going through that UI or the game itself. So, and I kind of went over a design doc before, but it's basically like the master blueprint, sort of as you can see here with this little house, of your game. Everything in there that you need to make your game should be in that design document. You can see here they add pictures and stuff. It's a living document. That's another thing that's important. Once you start to develop something, you don't just kind of kick this to the curb. You want to keep updating it and have an up-to-date version. So, someone new comes on the team, they know where to go. Someone hasn't, kept up, they had something come up, they're gone for a week, they come back, they need to know what's updated and what's changed about the project. Next up is programming, or as I like to call it, technical wizardry. So programming is the means of creating all the behind-the-scenes magic that goes on that makes the computer do the cool video game stuff. Basically, this is all done through code. You guys all know this, I'm sure. And code can be really difficult to learn. It's intimidating for a lot of people, but I'm here to say that we have a great supportive community here of a lot of coders. And we would love to be able to help you guys get started with that, because it's a super essential skill that touches every part of game development. And if you are interested in working in game development it's a good idea to pick up at least a little bit of programming experience along the way. Doesn't have to be your main focus, but learn what a for loop is. So this is the first of my art set of slides here. So the first of these is 2D art, the old one. So it's like drawing and stuff. I'm sure you all are familiar with what 2D art is. So it's basically any art that's made in a two-dimensional medium. So it's not just your classic painting. It also applies to digital things, and then kind of gets into more different aspects where you have like the pixel art seen in games like Hyper Light Drifter here, or this sprite animation sheet. It can also represent concept art that you can see here with this attack animation, environment art used here. And then I did a nice little history thing here where we evolved from cave paintings to the Renaissance, and then finally our peak Undertale. Yeah, it's an integral part of every game. Even if it's a 3D game, it uses 2D, and the visual effects, the UI, 2D touches everything. Also, don't worry about getting pictures. We will post the slides afterwards. Yeah, so 2D is super important. Great stuff. There's a bunch of different things you can do. You can be character-focused, environment-focused. You can be more of a concept artist. And then 2D also has traditional animation, which goes along with it, which kind of gets into the dichotomy of 2D and 3D, where 3D is a lot of technical work to set up, but once you've done the setup work, it's a lot more easy to work with, versus 2D is a lot of, you got direct control pen on paper, but it's a lot more of a difficult medium to work in. Speaking of 3D art, it's computers doing crazy stuff and making light appear on screen. So basically, 3D art is the science, or computer rendering is the science of light applied to computers. It's basically trying to replicate what our eyes do and then project it on a 2D screen. So it's made up of a three-dimensional medium, just like 2D, and it has plenty of different sub-disciplines, which this is a little bit more specific, so I'll kind of go over each of these real quick. So you have hard surface modeling, which is what you see up here. So hard surface modeling is when you're going to be going in, you're going to be like adding cuts to stuff. You're going to be kind of like it's more like chiseling with wood or something, or doing woodworking. You're kind of putting stuff together piece by piece, cut by cut, doing minute details all at once. And then you have organic modeling, also known as sculpting, where you kind of just mesh a bunch of crap together and then you smooth it out, and then you kind of build detail like you're playing with clay. You're sculpting. So how you give, this kind of gray box mesh here, this beautiful looking sort of glossy material with this kind of green look here, that's all done through materials and texturing. It's a little bit more advanced for me to get into how all that goes. We'll do a workshop on it later, but basically 3D objects are given a 2D image that is a texture, and through a system called UV coordinates, those are mapped onto the 3D image, and then you end up with a textured 3D object. And the last thing is animation. So you can see here a skeleton. The way 3D animation works is you make your model, this guy or this guy, and then you add bones to the model, and then you just change the position of those bones like you're changing the position of bones on such a puppet. And then you just move the bone, and then you say, I'm going to keep that frame, and then you move the bone again, next frame, so on and so forth. Makes it a lot easier once you do get it set up, but it is pretty complicated to get this to where it is. It's also much more expansive whenever it comes to immersion for 3D games. It's a lot easier for people to get lost in a 3D world than a 2D world. A 2D world, as big as it can be, is still flat to some aspect. It doesn't really represent what we have here in the real world. 3D games especially allow us to really get into a world. There's nooks and crannies and places underneath things, and things you wouldn't see from a single perspective that if you take a look around changes things. Computer assistance also makes it a lot easier to work in 3D now than it used to be. It used to be that you'd have to do everything by hand, sculpting with clay, get all that, think about like a practical 80s movie or something. But now with computer graphics, you've seen the explosion, I'm sure, in CGI that's used in movies, and the great graphics that we have in games nowadays as well. And then finally, the weird sibling, technical art. This one is for the indecisive people who can't decide if they want to be an artist or a programmer. This is me. I can't pick one. I like them both. So technical art is the bridge between a game's art and its software. So because we're using computers to do all these cool artsy things, you're working with like, images in Photoshop, or you're working with 3D models in something like Blender or Unreal Engine. All that's done through a bunch of different code and tools that the programmers have made. And this kind of sphere of programming and art that are together is the field of technical art. So it has a bunch of different really wild, kind of crazy subdisciplines that have some things to do with each other, but then also completely nothing to do with each other. Like rigging, for example, is the adding of those bones to your puppeted skeleton. Has nothing really to do at all with shaders, which is using graphics code, as you can see here, to make different visual effects. Then you can also combine shaders and texturing, like you saw in 3D models, to do specifically visual effects. And then there's also a rising field of procedural generation, which you can also see here, where got a couple function nodes that this guy's using. He's got like a weird little wave texture here, and then he's multiplying it by a number, and doing some things and just seeing what happens basically. And as he goes up this chain, he ends up with a pretty interesting effect at the very end. So technical art, if you do want to kind of stay a jack of all trades, this is the position to be the jack of all trades. It does allow for a lot of specializations. Like within this, if I had to pick a specialization, it would probably be visual effects and shaders. Those are the two things that I do the most. But I still know a little bit about rigging, know procedural stuff. It's still kind of like a nice little bubble to stay within, even though it is more of a jack of all trades type thing. And then we have audio. So audio is kind of split into two parts. You have your music, or the game's score, and this is the score for the music composition for the entire game. So it's the music that's going to be used from the beginning of the game to the end of the game. All that goes into the score of the game, and that is the job of the composer for a game. And might have multiple composers. I think usually it's a pretty small team for composers, if I remember correctly. But we usually use software such as LMMS or other DAWs, which is a digital audio workstation, to do work with music. And then you can also do sound design, which this is where you get all the crazy sound effects and ambient stuff. And it's a lot more experimental, I guess, where music, you kind of have a lot of theory to learn, and it's, you're listening to songs and trying to make what sounds good. You're also kind of trying to make what sounds good in sound design, but it's more tailored to the specific situation that you're in. You got to make a guttural scream for an evil entity of eldritch horror, right? How do you do that? Some people would take two like hollow PVC pipes and whack them together, and then distort that, and then get a raw meat slab and smack it on a table, and then record that, and then change it up a little bit, and you kind of get these weird mix bash things of sounds that kind of come together. This is a picture of Audacity, which is a free audio mixing software. You mix all this together, and it comes out as one cool sounding sound, and that's where you get sound design. So pretty much all sounds outside of the music in the game is going to be the job of the sound design team. All right, and then finally, last but not least, are production and direction. So production is going to be a producer is going to be the person that is managing the team. They're making sure things are getting done on time. They're going to set deadlines to you. They're going to make sure that, they're using all the resources that you have available. You're using them well. You're not, putting 3 people on something that one person can do, that sort of thing. It's all about making sure that at the end of the day, the game gets made, and it's quality when it does get made. Directors are all about leading the team, hopefully to a successful release. So direction is all about kind of having a vision for where you want the project to go, and then being able to talk to all different parts of the development team and communicate that vision, have an agreed upon vision, be able to take criticism and evolve that vision with everybody as you move towards a quality product at the end. So you kind of got like the scheduling for production, and then you kind of have the team lead here, or the team that you would lead for directors. And I'm going to pass it off. Oh, wait, forgot about this. So the other important aspects that we didn't mention that are also really important, I forgot to put writing on here for some reason because I'm stupid, but writing's super important. Quality insurance, that's all the testing that goes into games, which is super important, especially towards if you guys ever do a project that's a little bit longer term. You'll want to do play testing, get it out to people. The more criticism and people that play your game, the more you'll learn how people are going to approach your game, and then you can make your game ready for it to be approached by people. Like, it's kind of hard to describe, but you'll make a game. You'll be like, this makes total sense. I don't need to describe it that much. You hand it to someone, they have no idea what to do with it. They're trying to press the B button to flip over or something, or they've worked themselves into a hole that you never even thought possible. And that's what playtesting is all about, is you get to find out, what people are going to look at and interpret from what you're showing them. And then based on that, you can change what you're showing them to try to get them to interpret the right things. And then you have media and marketing, which is more important if you're trying to promote your game and sell it, but it is a really integral part. Again, with bigger firms, you end up with legal, research, etc. And I kind of have some pictures of all this here. Yeah, a lot of important things that go into game development. I hope that kind of covers it all. I'll pass it over to Phillips for talking about developing with teams.
All right. So when you're developing your game, you're probably going to have a team. It's pretty difficult to make a game all on your own, and having a team, you get more ideas, more people with more specialized skills, usually can make your game a lot better. Different stages and levels of game development have different team sizes. AAA has hundreds of people. Like, usually these people will have one very, very specific role that they do very well. Indie, it's usually less than 50 people with more broad roles. You might have someone specializing in programming, but they're going to try to have a strong understanding of what their teammates are doing as well, so that you can really work together. And personal projects, game jams, that's what we're going to be doing in this club for the most part. It's going to be less than 10 people. People are going to have to do a bit of everything to hold it together. I think that's fun, and really starting off with personal projects and game jams where you are put in this role where you have to learn a lot of different things. It can set you up to understand what you want to specialize in the future, and really just have a better understanding of your teammates and what they do, because that makes a project go a lot more smoothly. In terms of roles, team director and leader is an important role that takes a lot of time. Generally, the lead designer and producer is in this role. At large companies, you would be managing a ton of people. On a smaller scale, we would typically, someone might be the leader, but they are probably also going to be a programmer, something on the side in our teams. This is for organizing the team, keeping on track, and communicating with every member of the team. You want to make sure your team is not working against each other. One person thinks this level should be this way and someone else thinks it should be another way. You want to make sure everyone's on the same page and working towards a cohesive goal, and that's why this is a specific role. Programmers, there's a lot of different types of programmers. There's UI programming, gameplay programming, on a really low level engine programming. And usually you'll divide your programmers where you need them to be. Artists, that can be a wide range of things too. You can have UI artists, 2D, 3D. If it's not taken by the team lead, the artist should be stepping up to guide the overall visual aesthetic of the game and generate the assets for programmers to use. And again, this is just a suggestion of different roles. This is what people usually end up falling into, but in your projects, you can design your team however you see fit. Scope is a really important topic, especially in the game projects we're going to be doing. It's the planned relative scale and size of your project, and you want to match this with the resources you have. So usually have people, time, money. These triangles up here show where making a quality game, you have to have time, cost, and a good scope. And you basically need to pick two of those things. Because we're college students, we have a little bit of time and not a lot of money. We're going to be focusing time with cost and scope in mind. Scope creep is the growth of projects' scope outside of your team's abilities. So if you're planning a project, maybe don't plan to have 50 levels in an open world in between them. Start small, have a concept that is good and fun, make a prototype of that, and then see where it can expand from there. Like if you have a month to make a game, and basically a saying I heard is, however much time you think something's going to take, it's going to take at least double. And that's something to really keep in mind when you're planning out your projects. Some helpful advice on scope. Like I said, everything takes longer than you expect, always. Start with a minimum viable product. Outline what you would be happy with as a minimum. Like maybe a minimum of 3 levels, a solid core gameplay mechanic, and some art assets. You wanna have something in mind where it's like, okay, if we can't implement everything, there is a bottom line where we can make a quality game. Give yourself a time limit on the game and the parts of it. You want to basically design stretches. If something's not done by a certain time, then it kind of tells you something about your scope, and you might need to refactor that. And yeah, whatever you think you can do in a 40-hour work week as students, that's probably going to take a semester. Yeah. So I'm going to pass it to Aaron to talk about software and development tools.
It's the front one.
All right. So there's so many different types of jobs within a game development team. There's a lot of different software that everyone can use. We'll start off with game engines. This is what you build your game in. There are many that are free to use for the public, but also a lot of companies have their own that they build in-house that are private and they don't let anyone see. The ones we will mainly be using in the club are Unity and Unreal Engine, which are two of the biggest free game development game engines. There's also Godot and Game Maker Studio, which are also good options, and we have members who have experience in those. One of the biggest questions is what is the difference between Unity versus Unreal? Previously, we only taught Unity in this club because we found it was a good intro to game engines. It's a very simple design. C# we found is much easier to code in than C++ for beginners. And so we decided on Unity. But here are some differences to highlight. It's much simpler to get into. Unity really excels in 2D games. Unreal does have 2D capabilities, but Unity really leans into those. It's much less demanding on a computer. My laptop cannot run Unreal Engine, which is why I use Unity on it. I have to go home to my desktop to use Unreal Engine. It is a beast. Unreal 4, you can maybe, some people can run on their laptop with some difficulties, but Unreal 5 is just on another level that many people can't handle, which is another reason we use Unity in Club, because many of us come here with our laptops. But for this semester, we will be teaching Unreal, and we will be using the desktops in the VR studio if people can't have laptops to use Unreal Engine. Unreal Engine has graphics, amazing graphics, as probably many of you have seen, such as in the Unreal demo they did, just insane. It is very popular in the industry, especially among AAA companies. Epic Games, which is right next door to us in Cary, they created Unreal Engine, so of course it's going to be what they're asking for internships and job applications, if any of you are looking to apply. They also have their Blueprints, which is their visual scripting, which is amazing for anyone who isn't a programmer. What the hell was that? Programmer, but wants to get in, make a demo of some sorts. If you're an art person and don't know much about coding, Blueprints is very simple to use and very easy to get a base demo of the game you want. They also have free monthly assets in the asset store, which are really nice. They have combat animations out right now, which I got because I can't do animation. So whenever I want to do a demo that has combat in it, I'm kind of stuck, except for when they have free assets. They also have an amazing built-in AI system, so that you don't have to do as much customization on your own. Unity has built-in AI, but Unreal kind of really fleshed it out. They also are more easily scalable for larger projects. Not a huge problem, most likely within Club. I don't think any of us are planning to make AAA games in here. But yeah, Unreal Engine is also entirely open source. So you can see all the code that goes into creating Unreal Engine. And also they use C++. And then here are just some games that use Unity, and here are some that use Unreal Engine. 2D art software. I'm not an artist, so I haven't actually used any of these, but I will talk about them. So there's several different 2D art softwares that you can use, such as Piskel, Sprite, Krita, and Adobe Photoshop. Or if you want to get more advanced, there's Microsoft Paint. Yeah. But yeah, so for 2D art, you can Krita and Photoshop are great for like if you want to do painting or just character assets, whatever. And then if you want to do a pixel art style, then Piskel and Sprite are great. I believe Sprite is paid, right?
Yeah, Sprite is paid. Photoshop is paid. I will also state that Photoshop is also very good with pixel art if you have it.
Okay, and Photoshop is also good at pixel art. Yes.
Will you be like required to pay for some of these paid platforms, or does that come with like?
Oh no, you don't have to get any of these. You
Yeah.
can use any software you want in the club. We do not have any requirements. Yes.
I was going to offer some alternatives for Photoshop. If anyone's thinking about that, there's a free program that's very similar called GIMP, G-I-M-P.
Yeah, GIMP is also very good. And also, there's a lot of free like pixel art websites you can use. Like they're much more simplistic, but they get the job done. Yeah. 3D modeling software. The main two that we encounter are Blender and Maya. Maya is paid and very expensive, but it is available on a lot of the school computers if you're able to access one of those and use it on there. Blender is entirely free and open source, and they're constantly updating it, and it's a really amazing thing. Most companies many companies still use Maya, but a lot are switching over to Blender. So both, like the experience in both is important.
I will add in real quick that Maya, while being expensive, it is free for students. You have to just go sign up with your student email on the Autodesk website to get it. Very nice if you're trying to do that.
Yeah, you can get a lot of free stuff from your student email, including Maya. And then this 3D art you can make. All right. Oh, I also forgot to add music on here, but as he mentioned earlier, there's LMMS, right?
LMMS, yeah.
LMMS for music, and then I completely forgot what the other one was.
Audacity.
Audacity for sound effects and such.
And so when you're getting into game development, there is like if you were to do it completely blind, there you would never know where to start. It's a lot going on, very confusing and overwhelming. But there's a lot of e-learning resources. It's become extremely popular in the last few years for like guides to be put on YouTube, for example. Unity Engine is really, really great in this regard. There is a huge community around it. Brackeys is a YouTube channel which might be outdated in a few years, but for now he has a lot of good like getting into Unity and understanding the concepts videos. Code Monkey continues to make great videos for Unity. It's a little more advanced. Valim is a rising YouTube channel that has been making virtual reality guides. So basically, if you had never touched Unity before and you watch this guy's videos, you could make a virtual reality game yourself. It's a lot more accessible to make VR games than one might think. Unreal Engine, I have always found it a little harder to find tutorials for Unreal. But Unreal Sensei is a pretty good channel. He has some very long videos that basically give you a 3-credit-hour course on Unreal. Unreal can be used for a lot more than games, and so a lot of guides on the internet will focus on all its other capabilities. A lot of companies use it for film now. A lot of companies use it for games. It's a very versatile software, and so when you're looking online, you'll find a lot of different resources for different things, and you just kind of have to figure out what you want to use it for, and there's plenty of resources for that. Godot Engine, GD Quest is kind of king for this. They have a lot of great videos on using Godot Engine, and we haven't really touched like Unity and Unreal are kind of the comparison engines that most people use. But the advantages of Godot, it is extremely light. If you have a potato laptop, you can run Godot. And it's growing, and it's free and open source like Unreal is. So that's one to consider. For Blender and 3D modeling, There's a few channels here that are really good for getting into those. Blender Guru is the guy with the donut video, if any of y'all have seen that. If you want to, I guess, the rite of passage for a 3D artist, make your first donut, you can go to his channel. For game design, Game Maker's Toolkit is one that's just fun to watch. I think a lot of people, even who aren't even in game development, watch them, but they have very entertaining videos and they cover a lot of topics that are pretty relevant to designing games. For 2D art, I have no clue who this person is. I was just recommended them, so y'all can check them out if you're interested. So readings and other resources, Unity, Unreal, Godot, Blender all have pretty well documented documentation. I can speak on the Unity and Godot side that reading through it is pretty, gives you a good idea of what's going on and how to use the tools. Unity Engine and Unreal both have really well kept forums where you can go post questions. You can look if other people have had similar questions and read stuff. Usually if you Google a problem about one of these engines, you will come across the forums where someone else has asked that question. So that's very useful. We talked about Unreal Engine's asset store and how you get free assets from them. Unity also has an asset store on the web with a lot of good free assets that you can use for your games. Especially in the club, if you need like a sword or something, you don't care what it looks like, you can go to that asset store and grab one. So does Godot doesn't have as good support for assets, but it does have an asset page. For art and animation, Mixamo is a great place for character animations. It can automatically rig and give you a ton of animations for a 3D character, which is super useful when you're trying to make a game really quick. Open Game Art is a website with 2D and 3D art that's completely like free to use however you want. It's a good place to go. Sketchfab is a good place to look at 3D models. A lot of people go to sell models on there, but there's also free ones. And if you're a 3D artist, Sketchfab is a good place to kind of build a portfolio by posting things. And I guess talking about Sketchfab being a place to produce things, we also use itch.io as a really good website for posting your game builds and sharing them with other people. And that's how we do our game jams usually. I think that's the end of our slides.
So I will hop in here and say that on top of all those resources, you also have the resource sitting all around you, the rest of your club members. The goal of this organization is to help prop everybody up by, having a community of fellow game developers to support each other. I know a lot about 3D modeling after being here for 4 years. I would hope that if you're interested in that, come talk to me and I'll try to teach you everything I can. Same thing for everyone else out there. Try to learn what you want to learn. If someone else has questions, don't be afraid to help them out. And, the best way to help somebody is to, if you don't know, say you don't know, but try to work with them on the problem. And then maybe you'll both learn something. And then after that, I'll open it up for questions. We kind of have had it a little different every year, honestly. We're trying to do a different thing this year where we make teams with officers on them so that we have someone that has gone through this a couple times that doesn't, end up with a project that's trying to be a 3D first-person shooter with 10 levels that's going to have 12 different enemy types and is going to do all this other stuff. You're not going to be able to do that.
Yeah, we usually game jams, as they've conventionally been done, go over a weekend, so you have 48 to 72 hours to make a game. Because we're students and we have classes, we usually do our game jams once or twice a semester, and we stretch them out for a whole month. And we let people pick their teams. We usually have an ideation phase where we throw out ideas and talk about our ideas. But yeah, this year we're going to try to do it a little different. We're going to let people group up with people they want to, but we're going to try to really make officers who know what they're doing a resource for the teams, because like Mitchell said, we want to be a resource for everyone, and we want to see what kind of games y'all make, and we want you to feel like we're here to empower you to do that.
Right, back there.
Are you going to be doing any general itch.io game jams with the club, or more in-house?
Yeah. So of the two that we do every semester, only one of them is our jam. And then the other one we actually just got is the Red Storm Jam. That one is going to be over a weekend at the last week of October. So it's October 30th to, or sorry, not October, September 30th to October 2nd. So it's about a month away from now. We'll be throwing out a form for interest if you guys are interested in that. I want to wait until a little bit closer because I know people's schedules can kind of fluctuate. But yeah, and then for the winter we do Global Game Jam, which is global. It's across the entire world. Yes.
For like big game jams like that, can you preemptively do stuff, or is that like I guess like cheating or something like that?
Usually that's against the rules.
It depends on the jam. Like Global Game Jam, you don't necessarily have to do it with everybody. Like last year, they opened it up for 2 weeks instead of just one weekend, but every site got to pick when it wanted to do it. And 90% of sites basically pick that last weekend. That's the normal time for people to do it. But if you wanted to submit something on your own, you had a whole 2 week period to submit early.
Okay, I didn't know if there was like a theme or something like that that you had to follow, so like you could just like make a game like months before and then send it back.
Oh no, yeah, it's a theme. Most jams, I think almost every jam I know of has a theme that you have to go through.
Also, I was gonna ask, so like, would it be kind of like that jack of all trades thing? If you like wanted to do like a different piece of game development, like maybe each year that you're in the club. So if you're in like the club, maybe like all throughout college, like would it be better to like kind of like pick one part of game development all throughout college, or like if you spend like a year focusing on like different parts of game development, would that still?
It depends on what you want to do.
Yeah.
Okay.
Like if you're looking at it to have fun and be a hobby, then however you want to do it is the right way to do it. But if you're like trying to make a career out of it, like if you're wanting to work at like big AAA studios, having something you're specializing in would definitely be.
It's better to specialize if you want to like make a job out of it.
Yeah, kind of. But if you're also looking to maybe get into like indie development scene, knowing some more stuff is definitely useful. But the larger the studio, the more they'll want you to be specified. And so if you're looking for jobs, you can keep that in mind. But if it's a hobby, you can do whatever you want.
I will also add to that. A lot of jobs will take a more general position for juniors, so you don't have to be super duper specialized. Like you don't have to be a specific UI programmer, but you might go into like a company's programming team, and then they'll say, they'll test you out on a couple different things, and then say, okay, you seem like you're pretty good at UI programming, so we're going to move you kind of up the UI programming track. And that's you can kind of do the same thing here. Make games, and then after you've kind of had experience trying stuff, like it's fine to be a jack of all trades at the beginning. And then after you find what you want to do, keep doing that, and then you will eventually kind of specialize yourself.
You'll accidentally specialize anyway if you really get into game development.
That makes sense. I mean, like right now with y'all like introducing everything, I'm like, wow, like everything kind of sounds sort of fun to like get into. So,
Yeah.
Yeah, that's how I felt at first too. But then after I like worked on a few things, like I realized that I find programming really fun, and so that's what I've kind of stuck with. But, yeah.
All right. Yes.
I'm being completely honest with you here.
Yeah.
Like, I'm pretty new to all of this. Is this a good place for me to like learn?
Yeah.
Yes.
Of course.
Okay.
This is.
I just wanted to make sure that it wasn't something like, oh, you just come in.
If we were expecting you to come in with experience, we wouldn't have given this presentation.
Yeah. This is the beginner course 101.
Okay.
Yeah, because we do this mostly because the games courses offered at the university are for the games concentration in computer science or really high level art and design courses. And for anyone outside of that window, we want to be able to allow you to learn game development. That's why we kind of put all this on so that a beginner that has no experience can come in and actually learn what everyone else is doing.
This is a really good place to be, especially if you're going in that game development concentration.
I'm not planning
Okay.
to.
Gotcha.
I plan on. I want to see if this is something I want to do as a hobby.
Yeah.
Awesome.
To add to that, a lot of the NC State courses are for game design. They're a little interesting. Like, there's not a whole lot of Python involved, which is a language that I would highly recommend learning. I'm currently, along with a lot of the officers in a game engines foundations course, which is like has to deal with C++, but again, we don't have a whole lot of like. We took one class that was like C for like 90% of the course, and then 10% of it was C++. I would recommend like this is a great place to like also like branch out into the different languages. I would say because NC State is also primarily Java based as well.
Yeah.
Which sucks.
Yeah.
Java.
Yeah.
Not a lot of companies use Java anymore.
Yeah.
Yeah.
And sorry, go ahead.
Yeah.
Yeah, the game development track here kind of takes you from a intro game development class to dropping you in the water with a lot of conceptual stuff.
Yeah. A lot of us were up very late last night finishing our homework.
Didn't sleep.
Yeah.
Don't be me.
They also
But if
don't
you're-
teach any game engines. They don't like teach Godot, Unity, Unreal.
Yeah, like
We made our
I'm
own
in
engine,
I'm in the class that's supposed to be the first class where you learn Unity, and it's literally just go make a game in Unity. Like they don't like there's no class that lectures you or teaches you about any of this. It's very much learn on your own, which makes this a good place to be if you're in the concentration. If you're not, you don't got to worry about it.
To also put that in perspective, I'm in a data mining course right now, and it's only uses Python, and there are no tutorials about how to set up your environment or anything like that. You're expected to know at least some Python to at least get things working. So I was like spending time watching videos on how to do certain things in Python because the professor did not provide any of that physics. There's not like an intro to Python course that I know of here. Yeah, there is in high school, but not in college.
Yeah.
For some reason.
So like for all these different like language explorations, every engine that we kind of support, being Unity, Godot, and Unreal Engine, each has its own thing. So Unreal has Blueprints, which is great if you're not into programming at all. Blueprints is all visual. It's like nodes. You just kind of drag them out, you drop them, and you connect them with lines. You learn. I have not used GameMaker, so I don't know. But it's called visual scripting, so I'm sure I know Godot has its own version of
It's
it.
become a popular idea for game engines. I think every game engine has their own version of it, and Unreal's is Unity's is dinky. Godot's trying hard, but Unreal has it down.
Yeah. So if you're not into code, that's really good. For Python, Godot is in GDScript, which is built on top of Python, so it's a little specialized. Unity is similar. It has its own package that's built on top of C#. And for all you people that are like, oh no, what's C#? I don't know that language. It's just Java. It's Java. It's Java with a different name. It's Java. And then for all you people that really want to get nitty gritty with it, you can get into the bottom half of Unreal Engine, which is the C++ stuff. And that's where stuff gets real fun and interesting. I found out the hard way last semester when I tried to make a networked multiplayer game. That sucked. Yeah. All right. Yes.
Is it like more complicated to make a game like multiplayer or online?
Yes. Yes. So the way that online works, I actually have whiteboards. I can just demonstrate. I know things. I developed
That
my
doesn't work.
So basically the way
Mitchell,
that
that marker
networking
doesn't work.
works. What?
That marker doesn't work.
It doesn't work.
Wow.
Really cool.
Alright, can everyone see this board? Yeah, most part? Yeah, okay. So essentially, we're derailing a little bit here, but this is an interesting thing. So the way that multiplayer works, you get a server, that's your server, and you have a bunch of clients. These are your clients. These are all the players. And now what each of these individual dots here, circles, they all have a game state. But the authoritative game state, the game state that is, if anything happens, it happens there, and it gets to tell everything else what to do is this server. This has got it's got the crown. It's the king, right? So all the clients are running their own version of the game, and then they say, okay, I want to jump or I want to move forward. It's going to send that command to the server, and then the version of you that's on the server is going to move forward, just like this one will, right? Because nothing's changed. But say another player kind of runs over here, and now they're in your way, and they're going to block you, but there's like lag going on, so you don't see that here. So on your screen, no one's here, but on the server, someone's there. If you keep moving forward, you will run into that person, and then it looks like on your screen you're not touching anybody, but you are hitting something because in the server you're hitting something. and this is the authoritative game state. So whatever all these guys are sending here is what you have to keep track of. And then this also then sends all the information that it has back down. Like that.
Basically,
Sorry, yeah, go ahead.
if you think making one game is complicated, when you do an online multiplayer game, you have to be running X number of instances of that game and having them communicate with the server and receive information and not explode. Like it's
And because of lag, the most confusing part is that since you get so much lag waiting on this to go up, do its thing, and then come back, you actually just have to run a virtual instance of the game that is doing this, and then as soon as something happens in this real instance that's not like supposed to happen, then this updates. That's where you end up with, if you're shooting somebody or you're standing behind cover and someone shoots you through the wall, how'd they get me? Because on your personal instance, you moved back behind, but that didn't move the server version of you back behind. So you were still open in the server because of lag or something.
there is though like we're talking about how complicated it is, but there are shortcuts and it is entirely possible to make networked games. Like I know Unreal is trying to have their own in-engine support for it. I think it only works if you put your game on the Epic Games launcher, but I know like for me, over the summer I've been working on network with Unity, and there's a plugin called Photon, which allows you to support up to 20-player multiplayer for free, and it cuts out a lot of the legwork of this. And so if people are looking to learn about making a networked game and you're good with doing it in Unity, you can talk to me, and it's not that complicated with Photon, which is nice.
All right, and I remember you had your hand up next.
Yes, I was wondering, I don't know exactly how to pronounce it, but what do you think of Twinery?
Oh yeah, Twine. Twine is really great for a narrative game if you're interested in writing, especially, and you don't really have time to devote to like learning Unity or something like that. Go mess with Twine. I know that there was a Game Jam game last fall that basically took Twine's MO after doing it for a semester, and they just like ripped it out and put it in Unity. And yeah,
That actually brings up a great point. CSC 281 is open to anybody, and it is a class about game design in general, and the final project is a Twine project.
Yeah, that's a good thing to bring up if y'all are interested in game development. I think for almost every other major that's not computer science, this class counts as an interdisciplinary studies, so you can fill it in for your GEP. But basically, it's a intro to game development class. You play games and write essays on them, which is fun, and then you have to make a Twine game as one project, and then you just have to make a game for the other project. And they have resources where you can make that pretty easily, or you can do whatever you want with it. So that's a good class to take if you're interested in game development, even as a hobby, if you need to fill that interdisciplinary studies.
So this 281.
CSC 281.
if
Yep.
you want to see what Phillips made in their last semester, it's up on our website as our featured game this month.
Yep.
Yeah. You have a question?
I was just going to ask about if at some point we're going to have to learn the distinction between object-oriented programming and procedural programming. That's going to be important.
If you're taking C 230, you might, but if for here, no.
For here, you're basically going to be using the conventions. I mean, unless you write your own engine, which power to you if you do, you're going to be using the conventions of the game engine that you're using. And so it's going to, I don't even know, what would you call the way Unity and Unreal handle things?
I mean, it's basically object.
It's basically object oriented. So the paradigms are there, but you don't have to worry about learning how to program in different ways like that.
Any more questions? All right, cool. We'll move over to the VR studio for anyone that's interested. We'll be just helping people get like installed software. We're gonna just be going over how to install Unity, Blender, basically the stuff that we'll be using in workshops. So,
Yeah.
Oh, more questions? Okay.
Just on something you said.
Yeah,
Are we using Unity or Unreal?
we'll be using both. So
Whatever
if you're,
you want.
if you're new, we recommend you go to Unity, but we'll be basically holding a workshop for both when the weeks we do it. Next week, I believe we're going to be doing the intro to both at the same time. We'll be recording them, so you'll be able to watch one later if you missed the other one.
Because I already had Unity. I already have Unity installed. I installed it off the recommendation of one of my high school teachers, but I do not have Unreal.
That's I don't have Unreal on my laptop either.
Yeah.
So,
I have it on mine, but it basically killed my CPU.
all right, Red Shirt, did you have a question? Okay.
Yes.
Yes. You can get on the computer in there and use it if it's open. Yeah. That's an advantage of having the VR studio for our meeting is we have computers for people to use.
Yeah. No. Okay.
Okay.
All right. Yeah. Cool. Great.